So, hello, this is Elochukwu from Prime Academy. So now what we'll be looking at is, I'll be using these values to still illustrate how we can choose a suitable scale. I'll be using that to still explain. Then from that, I'll show you how to plot graph, how to get error in slope, and then error in intercept. So I'll be using this to achieve all of these things. Then at the end of this, we'll be looking at an experiment, a rectangular prism experiment, how we can calculate the values we need, like I told you, without having to probably do the experiment in the lab. So we can calculate them and get all the values we need to plot our graph. So we'll be doing that, but then for now, we're going to illustrate how to choose scale again with these values, because we'll be plotting a graph of sine I against sine R. So like I told you, when plotting graph, very important, we don't say y-axis and x-axis. I hope you understand that. So while plotting graph, we don't say in physics, we don't say y and x-axis. It's only in mathematics. In physics, we talk about what you are plotting, that quantity. So if it is sine I, we say sine I axis. If it's sine R, we say sine R what? Axis. Very important. So for your graph, the first thing you put is what? The title. That's the first thing. For you to plot your graph, the first thing that comes there is what? Title of your graph. The next thing is what? The scale you are using. You understand? So, and then scale is what I'm going to repeat again. I've done that in the previous video. I'm going to repeat that again. Now, let's assume we are plotting this graph. So these are sine I axis, and these are sine R axis. So we're plotting a graph like this. Now, how do we choose scale for the sine I? Like I told you in our previous class, we're going to be using the concept, the range. So what we'll do, we look out for the highest value here. So looking at these points, the highest value we have here is 0.94. And the lowest value we have is what? 0.5. You understand? So to get a scale that will be very suitable for the graph, we're going to do the range. Now for the highest value, in order to accommodate all these values, for the highest value, we approximate this to the next number that is immediately greater than this. It's not the normal approximation you do, but you just take this to the next value that is bigger than this. You understand? Of course, this is 0.9. So the next value bigger than 0.9 is what? 1. You understand? So that 1, why we are using 1 is so that it can accommodate this. If you use 0.9 to be, it won't accommodate 0.94. If you use 1 will cover this. You understand? Yes. So that is it. So between the range, so the range is going to be the highest for this one, which is going to be 1.0, right?
Yes.
And minus the lowest. So what we have here is 0.5. So we'll be using 0.5 as the lowest value. If we had something like 0.54, 0.53, we'll still be using 0.5 because it will cover it. Yes. You understand? So 0.5 is okay. We're going to start from here to this point. So our range is going to be what? It's going to be 0.5. This is the range. Now, to plot our graph. Now, if we have a graph sheet like this, we have a graph sheet like this. So what I'll do is, now, if I want, of course, if you're plotting graph, the essence of doing this to choose scale is so that you maximize this rectangle. Do you understand that? So if you plot a graph and you don't maximize this rectangle, your graph have a likelihood to be wrong, or your slope. So for you to get a better slope, you have to maximize this rectangle in the graph. So you try to plot so that you cover a good portion of this area. I hope you understand that.
Yes.
Now, so I will check. In total, I have, of course, each box here represents 1 cm. If you use your meter rule to measure each box, it is 1 cm. Sometimes you measure, it's not up to maybe close to 1 cm, but it's not exactly. You assume that it's 1 cm. And then 2 boxes will be what? 2 cm. You understand? So, but then most of the times it's better you use 2 cm. So I'm going to, now if I want my graph to cover 8 boxes, I'm going to count I will count them in twos. I have from here to here is 1, that is 2 boxes. From here to here is 2, 3, 4, 5, 6, 7, 8. So I've counted 8 boxes in twos. So it means if I want my graph to cover 8 boxes, then I'm going to divide that range by 8. Remember, the 8 I counted here is what? I counted 2 boxes as 1. The reason I did that is because I want to use 2 cm. If you want to use 1 cm, then you'll be counting 1 box as 1. I'm counting 2 boxes as 1 because I want to use what? 2 cm to represent that unit I'll be choosing. Do you understand? So since I want to use 2 cm, I'll be counting 2 boxes as 1. Do you understand me?
Yes.
So counting 2 boxes as 1, I want my graph to be able to cover 8 boxes. So what I'm going to do is I'm going to divide the range by 8 boxes. Do you understand that? So if we divide the range by 8 boxes, we'll have what?
0.0625.
0.0625 or so. So we can leave it at 0.06. You understand? So you discover that this is going to be my what? It's going to be my scale. Now, but the thing is, this concept tells you that you can choose, even if you don't like to use this scale, this is already a guide telling you that your scale, any number around 0.06 will work for your scale. Do you understand? Now, me personally, I would not like to use 0.06. The reason being that is difficult to add up 0.06. You understand? So it means I'm going to use 0.05. 0.05 is a number around this, it will work. 0.07 would work because it's around 0.06. Even 0.04 would work. You understand? And I'll be using 0.05. Why? Because it's easy for me to add. So after 0.05, if I choose the first point, if the first point is 0.05, the next one is going to be what? 0.1, right? The next one is going to be what? 0.15. So it's easier for me to add, unlike when I'm using 0.06. You discover that adding it will be difficult, except you're using calculator. So, but you can still use 0.06 as your scale. Is that clear?
Yes.
So that is how simple it is. So we'll be using a scale of this now. Discover that would be a suitable scale for this. Then looking at this other one, the same thing. It's just the same concept. Looking at this other one, we have what is going to be our range. The highest value we have here is what? 0.768. So the next value that is immediately greater than this is what?
8.
0.8. I hope that is clear. Minus the lowest value is going to be what?
0.3.
0.3. Because 0.3 is less than 0.358. So the small value is going to be 0.3. So what is the difference now? The range.
0.5.
0. What? 0.5. So this is the range. Then we still divide. We are fortunate we're still having the same. So the same concept is applied. Looking at the horizontal, of course, you know the number of boxes you have on the horizontal axis is less than what you have at the vertical. I hope you know that.
Yes.
So you don't choose 8 again. If you choose 8, you may not enter. So you go there and count so that you know how many you want it to enter. You understand? So if you still decide you want to use 2 cm, it means you're going to be counting 2 boxes as what? 1. If you want to use 1 cm, that is 1 box to represent 1 unit. It means you'll be counting 1 box as 1. I like to use 2 cm, so I'll be counting 2 boxes as 1. So counting this from here to here as 1, 2, 3, 4, 5, 6. So I may want to utilize 6. You discover it to cover a good portion of this. You understand that? So I'll be dividing my range by what? 6. So when I do that, to give me an idea of my scale, so punch that on me.
0.08.
0. What?
0.08.
0.08. So this is a good scale. This is a scale that will work. So all you need to do is to keep adding. You can use your calculator to add that. You can still use 0.07. That is around it, it will work, but don't go down up to 0.05. Discover it will be difficult to enter. The number of points won't enter. But if you have a bigger graph, you can use 0.05. Or you can use this. Of course, your calculator can add this. You can use 0.08. That's a good skill that will also work for that. So when you're using this concept in getting your scale, you are sure. You are sure of your slope. You understand? You're sure of what you get. It would always work. But if you want to now, the way you do it, you discover that everything will squeeze in one small space. You should be conscious of that. That's it.